Recording is rolling. So, oh yeah. I'll get you guys 1 minute. Alright, so today is going to be a Friction Lab day. I'm going to remind you guys where we are in the big scheme of things. So yesterday we were looking at AP Classroom multiple choice questions. I wanted to give you guys more time for very non-frame, but here's how we're going to have to do very non-frame. Is I left all the materials back there. There's some setups, there's some string stuff. So if you guys have a little bit of spare time today, you want to get your hands on that, you can. I went ahead and just put points in the grade book because you guys were working on this on Friday, but we're just going to have to do it that way and then move on to other stuff, including Friction Lab today, FRQ tomorrow, more labs on Thursday, Friday. Remind you guys that Open Notes take-home quiz is due Friday. Some of you guys have turned that in already. Also, federal impact forms are due by Friday, and some of you guys have turned those in already too. So if you have those and throw them in the grade tray, you can forget about that. So what's up with this Friction Lab? Well, this Friction Lab is going to be in two parts, two different perspectives. And I won't tell you enough to give you guys some hints so you know where you're going and what you're doing with this, but maybe a little bit of hints so you can sort of figure out what's going on with this too. The question's going to be related to something to do with coefficient of friction. Like, what is the coefficient of friction? So there's two different lab setups, two completely different lab setups. Now, when you guys do the write-up on this, just pick one of those. So you don't have to do the write-ups for both. I do want you to get data for both, which you guys will have like the perfect amount of time in class today to get data for both perspectives. And I'll demo those for you guys so you know exactly what's going on. But for the write-up part, just pick one of those and write the procedure for it. Now, tomorrow in class, I will break out AP style grading rubrics for each of those, and then I'll have you guys break out the colored pencils so you can grade yourselves and figure out how many points you got. Okay, like we normally do this thing. Okay. But yeah, if you keep a pretty good pace and you make good use of your time today, you should be able to do this all in class today, and then I'll have you guys do the grading part tomorrow. Okay, so the first part, the left half, says what's weight. Maybe you can pick different weights. What's the pulling force, and then what's the ratio of those. Now, I did not explicitly spell out all the important details, but I think you guys can figure out some stuff, and I'll demo for you now. So pick several different lab weights. Hey, why did I wrap this thing in paper? What's that about? Wrapping it in paper. Yeah, trying to control for materials. Remember how this coefficient of friction is a material property between any two particular surfaces? Maybe it's between like aluminum and cedar wood or something, right? So your lab weights, if you pay real close attention, some of them are just bare metal, and I don't know exactly what metal, but something. And some of them are painted in black paint. So that's completely different materials, isn't it? So if you really want to be scientific about it, then you would control for the materials. So in this case, maybe it could be paper against paper, something like that. Now, two important details that I left off. One is that you're pulling specifically horizontally, and the other detail that's important is that you're pulling at constant velocity. So pull horizontally at constant velocity. Now, why are those details important? Well, when I sketch up a free body diagram, actually, you know what? I've got one here. I'll just save you guys a hot minute. Just throw this up here. Then you can see why. So if you pull this at constant velocity across the paper surface, then, well, here's the free body diagram. There are four forces. There's its weight pulling down. There's the normal force from the surface holding it up, which, as long as there's no other vertical weights, then could these two be the exact same magnitude? Right? That's why you want to pull horizontally, because if you pull not horizontally, then the normal force could not be equal to the weight, right? You guys get that? Yeah. And then why pull with a constant velocity? What's that important for? Why pull at constant velocity? Yes, there's.
So that way the free body diagram stays in equilibrium.
Yes, yeah. You guys heard Derek? He's saying they'll put this in equilibrium, which means that whatever the pulling force is, which is something that you can directly measure in newtons on a spring scale, that's some number of newtons, that would also exactly represent the friction force, wouldn't it? Right? So that when you guys are trying to figure out what is the coefficient of friction, which is defined as the ratio of friction force over normal force, the ratio of these two guys, well, you could use for stand-ins for each of these forces something that is directly measurable, which is to say the weight for the normal force and the pulling and the and the pulling force for the friction, right? So the same ratio. Okay, you guys get that? All right. So once you guys do that for several different lab weights, graph, it says pulling force versus weight. Now you guys have done enough graphs in here that you know that that's means y versus x for the axes. This is force pull versus weight. That's what those axes are. And each of those has units. What are the units for each of these axes? Is it kilograms or newtons? Newtons. Pulling force is measured in newtons. Weight is also measured in newtons. Hold on. What's kilograms? That measures not weight, but mass. Right? Mass is like amount of inertia. Weight is like the gravity force from the Earth measured in newtons. Right? I got a couple of questions down here, but see where it says F pull equals? Hey, F pull, that's like your y-axis. Do you think this is like y equals something? Maybe I want you to make an equation. I wonder what this graph looks like, and therefore what the equation of it is. And then, how does coefficient of friction enter into that? All right, so that's the first half. The second half is a completely different perspective, but on coefficient of friction. And while you guys are doing the lab, I'm going to leave this free body diagram on the projection, which will give you some good hints on the second half, because the second half is going to look something like this. It says, what is the weight? So pick different lab weights. You could probably just use the same ones that you used for the first half. Then it says theta in degrees. Now, again, I left off some relevant details. What theta am I even talking about? I'm talking about theta measured to the horizontal. So that's an important detail, right? Measured to the horizontal. And also, actually, there's two slightly different angles depending on what your perspective is. You might pick the angle that, say as you tilt this incline up, say I put this weight on this incline, and I'm just ramping it up. I still have paper versus paper, so that's still controlled. But at some point, it's going to break the friction and start sliding down. Right? Now, you might be interested in the angle that it first breaks the friction, or you might be interested in the slightly shallower angle that it would keep constant velocity moving down. So think about that. That might be two slightly different angles. I'll let you guys figure out exactly where you want to go with that. And if you were to do that on the lab write-up, figure out exactly how to describe that. I had a few questions earlier today on what do I mean by tan theta. So suppose, just for sake of argument, let's say the angle was like 11 degrees. All you do is pick up a calculator to get this last column and say what is tangent of 11 degrees. Right? As long as your calculator is in degrees, right? See a number, write that down. And I have not told you what that means yet. What the heck is tangent theta? Why would that be important? I'll leave that as an open question. But again, this free body diagram might help you out. I see a sine theta. I see a cosine theta. What the heck is with tan theta? Bet you guys might figure that out. Right, and then graph, see tan theta versus weight. So tan theta goes on this axis. Hey, what's the unit for tan theta? Yeah, unitless, right? Unitless. Right? And then weight, okay, well, that's in newtons, just like before. Okay. Then a couple of questions at the bottom, but all right. So if you guys don't have any questions right away, then I'll give you guys the rest of the class to gather all your data and also write the lab procedure on the back. So again, gather data for both perspectives, the lifting versus dragging and also the incline. Do a lab write-up for only one of those, and then tomorrow I will do a full debrief with you guys, and we'll do AP style score and that whole deal. Okay, you guys good?